right, this is Geometry B, Unit 7, Lesson 10. We're talking about the volume of a sphere. A sphere. You recall the definition of a circle. A circle is all points in a plane equidistant from one point. A sphere takes away the restriction of being in a plane. It's a three-dimensional circle. So, one of the things I like to do is I'll draw the equator of the sphere, and I'll draw the back side of the equator as a dotted line. Okay. And then draw the outline of the sphere. Or vice versa. You can draw the outline first and then draw the equator. Okay. But really the only dimension that you need to know about in a sphere is the radius. The radius, the distance from the center to the edge. Now, that isn't always what you're given. Sometimes you're given the diameter. So the radius is here, but the diameter is all the way across. And you should know that the diameter, dia being through, meter being measure, is twice the radius. So the diameter is twice the radius. The diameter equals 2r. Okay. I'm just going to give you the formula. The lesson really doesn't derive the formula. To derive it takes a little bit of calculus here. But here's the formula for the volume of a sphere. 4/3, so 4 over 3, pi r cubed. Okay? If the radius is given in inches, radius is in inches, inches times inches times inches, or inches cubed, is the unit for volume, so it makes sense. 4/3 pi r cubed. Now let's say we are given a case where the diameter is 1, 2, 3, 4, 5, 6, 7, 8 inches. Then the radius is half of that. 8 divided by 2 is 4 inches. And the volume is 4/3 pi times 4 cubed. Okay? You can give your answer exact in exact form. Let me pull up Desmos. And to do it in exact form, I'm just going to leave the pi out. 4/3, right arrow to get out from under the fraction, times 4 cubed is 85.3333, or 85 1/3 pi. And by the way, in Desmos, you can hit the fraction button and say 256/3 pi. That would be exact form. Approximate form here, let's put pi back in the formula, times pi, and we get 268.08, or 268.1 to the nearest tenth cubic inches. So exact form or approximate form. Now, just like the other lessons, you can also be given the volume and be asked to find the radius or the diameter. Let's go ahead and do one of those. Okay, so once again, let's draw our sphere, an outline, followed by an equator, solid in front, dotted in back, gives the illusion of 3 dimensions. Okay? And we want to find the radius given the volume. So let's say the radius is right here. And let's say the volume is 500 cubic centimeters. So use the formula, volume equals 4/3 pi r cubed. Substitute what we know, 500 equals 4/3 pi times r cubed. Multiply both sides by 3. $1,500 equals 4 pi r cubed. Divide by 4. Four goes in 3 times. 4 goes in 7 times. 375. Okay, pi. Divide by pi. R cubed is 375 divided by pi. Take the cube root. So r is the cube root. So the third root of 375. Divide pi. Bring up Desmos. Okay, we get cube root. To enter cube root, there's a couple of ways to do it, but the simplest way in Desmos is CBRT. CBRT. 375 divide pi. And we get about 4.9. Approximately 4.9. 4.9 centimeters. Okay.